Hey guys, do you know what drives our vehicles forward and heats our rooms in cold winters? What keeps the huge factories running ceaselessly at high speeds? It all depends on energy. Today, we will take you into a new field to reveal how power is driving the rapid development of China's economy and the challenges that must be overcome to keep the wheels of the country under pressure for the ever greater need for environmental protection. But before we dive into our discussion, we kindly ask for your support by liking this video and subscribing to Machine Eye. Your thoughts matter to us, and we invite you to share your opinions in the comments below. Without further ado, let's embark on an extraordinary journey. Satisfying the electricity demands of its staggering 1.4 billion population, China has orchestrated a multifaceted approach that blends innovation, diverse energy sources, and strategic infrastructure development. This complex strategy revolves around harnessing conventional fuels, pioneering renewable options, and advancing cutting-edge technologies to power a rapidly evolving nation. In the Gobi Desert in northwest China, a group of engineers is searching for the enormous energy buried beneath the desert. A blasting engineer with 37 years of experience, along with his team, will use 1,418 tons of explosives to blow to smithereens a 38-meter thick layer of rock in an area the size of 5 football fields. At the same time, they must ensure that what goes up comes down in all the right places. The charges cannot be set off simultaneously, which would result in destructive seismic waves. Engineers choose to detonate the explosives in batches. There are 781 blasting holes divided into 12 groups. Each group will be detonated less than 1/100th of a second after the previous group. To make this work, the blasting team needs electronic detonators with an encoder. The operator must accurately control the ignition of thousands of electronic detonators in milliseconds. The Chinese have invested billions of dollars to build facilities in this arid inland area beside the desert to produce coal. The coal found here is of superior quality and has a very high heat value. It contains less sulfur and is therefore less damaging to the environment. Today, coal is still the main energy source that drives more than half of China's economy. This is one of the open-cast mines operating in China. The coal is of high quality, and the seams are very thick. Coal seams of over 15 meters in thickness are regarded as super-high seams across the world, and the seams here are up to 30 meters thick. Of course, to mine this precious coal, the upper layer of rock needs to be removed beforehand. After removing the gravel, a new coal seam reveals itself. The daily output of coal from this canyon is over 100,000 tons. It could generate enough power to supply one modern family for 10,000 years, but it's just 1% of China's daily coal output. Coal holds a primary position in China's energy structure. Because of that, it is particularly important to use coal efficiently. One of the most efficient ways is to build large power plants near the coal fields. This reduces transportation costs and keeps pollution away from populated areas, far from the cities. The west of China has substantial coal reserves, but it is very short of water, and that is a significant issue. Building a thermal power plant in a desert was impossible in the past because a traditional thermal power plant requires so much water for cooling. The boiler cannot operate without it. China has begun to construct large thermal power plants in the desert because it has found a solution. The secret lies in these passive cooling towers, which do not use water. As the hot air rises from the top of the tower, cooler air is drawn in at its base over an array of radiators. The 132 radiators are distributed in a V-shape. As this type of passive cooling tower doesn't require large quantities of water directly, it's possible to build them in the desert. The eastern part of China is home to just under 70% of the country's population and over 80% of its economy. However, most of the new energy resources are located in the west, thousands of kilometers away. Energy transportation has been a persistent problem for the country. China plans to construct more large power plants around the coal fields of western China, converting coal into electricity, and then transmitting the power through the grid to the east. This project constitutes the largest energy transmission project in human history. This power transmission line boasts the world's longest and highest voltage. It originates in the Yungar Basin in the far west of China and spans a distance of 3,324 kilometers, crossing deserts, mountains, and canyons to reach the densely populated east. This ambitious endeavor is projected to be completed in 8 years. China has built more than 30,000 kilometers of high-voltage lines to establish the world's largest energy transmission network. To increase the system's efficiency, the voltage needs to be raised. The 1.1 megavolt high-voltage line is currently the highest in the world. It can transmit the energy generated by 80,000 tons of coal over a distance of 3,000 kilometers in a day. To ensure smooth and efficient transmission, the 20,000 conductor joints must be perfectly connected. The cables are connected through intense pressure. First, the outer aluminum wires are stripped back to expose the steel core. Then, the two ends of the steel core are inserted into a metal sleeve. A hydraulic clamp presses firmly on the sleeve to hold the two sections of the steel cable together. After the steel core is joined, a larger sleeve is used to connect the outer aluminum wires. The workers need to hold the two ends of the cables carefully and avoid damaging the conductors while dealing with the 5-ton tensile drag on the cable. To manage this, they must use a special cable that combines strength and flexibility. The job not only requires concentration but also a head for heights. It will take 6 months to complete the new 3,324-kilometer line, and this is just the beginning. Historically, it has been very difficult for China to develop deep-sea oil and natural gas resources. The energy stored in the deep sea is beyond imagination. As the sea becomes turbulent, the test commences. The key requirement for accurate underwater operations is equipment stability, even in rough seas. In order to achieve this, the engineering ship must maintain a fixed geographical position against the flowing currents and heavy waves. This is achieved through the approach power compensator system. When waves push the ship off its position, the compensator system instantly activates the corresponding thruster to counteract the force of the sea. This keeps the ship steady. However, when the ship rolls or is lifted by the waves, the thrusters alone are not sufficient. But this new ship comes equipped with another special piece of equipment, the world's largest crane with an automatic height compensation system. The high-power crane is capable of lifting up to 400 tons. As the ship rises and falls with the swell, the crane automatically detects the speed and direction of the movement. It then reacts instantly by adjusting its cable lines or turning its lifting arm to compensate for the motion. To fully utilize these favorable conditions, the test must continue well into the night. Images from the underwater camera show that despite the surging waves, the 400-ton test box only moves slightly and remains well within the control range. Everyone is very pleased with the result. With the advancement of deep-sea engineering technology, humanity has taken another step in harnessing resources from the oceans. China has become the first country to successfully mine fire ice from beneath the seafloor. Fire ice, also known as combustible ice, is a common name for methane hydrate. It exists as a flammable solid in which methane is trapped in a crystal structure of water. Originally assumed to only exist in the outer reaches of space, it has been found to exist in extraordinary quantities on Earth, below the seabed. It forms the largest reserve of fossil fuel on the planet. However, extracting it is no simple matter. To date, reliable mining techniques have yet to be developed. China is making conscious efforts to increase the proportion of clean energy in its energy mix. Hydropower will play an important role in this endeavor. This is the construction site of the Wudong Hydropower Station, one of the 4 cascaded hydropower stations in the upper reaches of the Yangtze River. The excavation works have been completed to build a massive facility on the mountainside to house the giant hydraulic turbines. Engineers are planning to cast a seamless concrete dam. Concrete fracture is a recognized technical challenge, and the larger the project, the more serious the issue. There's a saying among engineers that every dam has fractures. It will take 2.91 million cubic meters of concrete to cast the Wudong Dam. The plan calls for a wall that is 275 meters high and between 12 and 51 meters thick to withstand the pressure from up to 270 meters depth of water. The dam cannot fracture, have even the slightest fracture. The key to building a seamless dam lies in the continuous control system. The casting process must continue uninterrupted for 33 months. Its uneven thermal distribution can lead to cracks. The key to building a seamless dam is achieving precise temperature control during the continuous casting process. However, abundant water resources are not found everywhere. The west of China faces water scarcity but enjoys ample sunshine. The power of sunlight and the duration of sunlit hours make it an ideal site for solar arrays. The key components of the array are these mirrors. When the sun rises over the Gobi Desert at 7 o'clock in the morning, more than 20,000 mirrors precisely reflect the light to the top of a tower. The generated heat is absorbed by molten salt, which carries the heat down into the plant where water is heated into steam to drive turbines for electricity generation. This method of generating electricity neither consumes fuel nor releases emissions, making it an ideal way to utilize solar energy. China has developed a precise sunlight tracking system for this tower-type photothermal power plant. Controlled by a computer, the 20,000 mirrors reflect sunlight to the top of the tower when aligned accurately. The regional conditions favor solar power, but there's more than one way to convert sunlight into energy. Not far away, another solar power plant 10 times the size is under construction. It is a trough-type photothermal power plant. Unlike the tower type, this plant collects sunlight heat through curved mirrors. Both systems, however, rely on precise solar tracking. After installation is completed, the mirrors will be aligned to within less than 1 millimeter. This plant will feature 9,120 solar troughs generating 50,000 kilowatts per hour. China's currently installed solar power capacity exceeds 70 million kilowatts, accounting for 1/5 of the world's solar generation capacity. The increasing ways to utilize solar energy will revolutionize China's supply of clean energy. Its rapid development showcases China's genuine determination to transform its energy structure. However, other emission-free energy sources remain untapped. China is one of the nations taking the lead in seeking renewable energy from wind. Giant turbines have become a common sight in various landscapes. While wind energy is often harvested more reliably at sea, the harsh environment presents significant challenges for turbine installation and maintenance. Previously, turbine generators were assembled on land and then transported to their operating sites by semi-submersible vessels for final erection. This process was costly, slow, and resource-intensive. Today, offshore wind power appears to be the future of wind energy, as breakthroughs in installation technology significantly reduce costs. On the eastern coast of China, a new installation method is being trialed. This newly developed tool can accurately set the blade's angle at a height of nearly 100 meters, aligning it perfectly with the rotor hub. If the machine functions as intended, the cost of offshore wind turbine installation will be significantly reduced. The progress of science and technology drives energy development, resulting in a mixed-source energy policy. On a remote peninsula in eastern China, the world's most advanced nuclear power unit is being prepared for operation. The nuclear reaction generates immense heat, which is used to convert water into high-pressure steam, driving generators to produce electricity. The core of a nuclear power plant is the reactor unit, constructed to the world's highest safety standards. Before commencing operations, numerous and repeated safety inspections must be completed. The engineers test a 3-story high safety door made of special metals and manufactured using aerospace technologies. Like the safety door, nearly 1/3 of the plant's components are designed with the ultimate goal of safety in mind. At the business end of things lie this 10-meter deep pool and the adjacent reaction chamber. The pool will eventually be filled with pure desalinated water. The installation and replacement of fuel rods will take place here. This area has seen countless hours of meticulous preparation, ensuring everything runs seamlessly. The last round of inspections is nearing completion. The nuclear fuel, ready in the fuel bin, is securely stored at the highest level of security. Over 100 fuel units, sufficient to power the plant, are ready for use. Below this floor lies a stockpile of the most powerful energy source humanity has harnessed. Its energy density is 2.5 million times that of coal. A mechanical arm delicately handles the nuclear fuel assembly, each composed of 264 metal tubes filled with nuclear fuel. Prior to startup, they were not radioactive. For 4 hours each day, the engineers' operations are rehearsed repeatedly to ensure a flawless startup when the plant goes into full operation. Nuclear plants operate on nuclear fission, releasing energy through splitting atomic particles. While immensely powerful, this process generates hazardous radioactive waste. By contrast, the sun generates energy through nuclear fusion, producing no radioactive waste. On July 5, 2017, Chinese scientists astonished the world's scientific community by achieving a temperature of 50 million degrees, a critical milestone in fusion research. However, no known material on Earth can withstand such extreme temperatures. A magnetic field provides the answer. The coil enters a superconducting state at low temperatures, generating the Earth's strongest magnetic field. Suspended within this field are the materials for a fusion reaction. Nuclear power, though controversial, remains a great hope for an endless, reliable, and clean energy source in its various forms. Natural renewables will also play a crucial role in meeting tomorrow's demands, while ingenious solutions continue to be sought for today's challenges. In the sparsely populated deserts of the West, the search for a better future, where needs are met and waste is eliminated, persists. China is committed to this clean, green future with all its energy. The journey through China's mega projects is one of awe and inspiration, a testament to Chinese ingenuity, innovation, and the relentless pursuit of progress. Each of China's ambitious undertakings stands as a testament to human achievement, underscoring how the fusion of creativity and resolve can lead to extraordinary progress. If you found this video enlightening, please show your appreciation with a thumbs up and by sharing it with others. We eagerly await your valuable insights and feedback in the comments section below. Remember to like the video and subscribe to our channel for a continuous stream of captivating content. Thank you for being a part of our viewership, and we're excited to engage with you in our upcoming videos. Let's continue to explore, learn, and inspire together. Take care and goodbye.